Welcome to part 2 of graphing the circle, the distance formula. The distance formula is this very imposing looking equation. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Let's take a concrete example. Let's say we've got 2 points, a point 1 and a point 2, and they are -3, -2, and 5, 4. Now, any point is composed of 2 parts, the x and the y. So let's see what these 2 points look like on a graph. Let's draw a nice, quick and crude graph over here. For point number 1, that's going to be for x, -3. This is the x-axis. This is the y-axis. X will be -3, 1, 2, 3, that would be about here. And the y-coordinate would be -2, -1, -2. So that would be about here. That would be -3, -2. And this point would be x-coordinate 5 and y height 4. 1, 2, 3, 4. So this is point 5, 4. And what we'd like to do is know what the distance is between these 2 points. And we can do that using the Pythagorean theorem. Now, the Pythagorean theorem says that if you have a right triangle, there's a fixed relationship between the sides. So if we make this into a right triangle by dropping a line down parallel to the y-axis and another line across parallel to the x-axis, and since the x and the y-axis are obviously at right angles to one another, 2 lines parallel to them, to the x-axis and the y-axis, will also be at right angles. So now we have a right triangle. And the Pythagorean theorem says that a squared plus the length of the b side squared is equal to the length of the c side squared. So first, let's find out what's the length of the a side. Well, to do that, let's see what this point here is worth. We know its x value is 5 and its y value is -2. We're down -2 from y equals 0. 5, -2. So this is the name of this point here. Now the distance on the b side is the y height. It's parallel to the y-axis. The distance on the a side of our triangle is, in terms of x, it's parallel to the x-axis. So x2, the second x point, the further one over here would be 5. And we're going to subtract from it the x value over here. So that would be 5 minus -3. In this way, we take account of where it ends up and where it starts off. All right, so this is going to be our x length. And our y length is going to be the higher y point, in this case, a 4. And to take account of the fact that it starts, this y length over here, starts at -2, we're going to subtract that -2 from it. So 4 minus -2. And here we've got the a side and the b side, the x length and the y length. Now we know that by the Pythagorean theorem, when you have a right triangle, the a side squared plus the b side squared is equal to the c side squared. So since this is the a side squared plus the b side squared is going to equal to the c side squared, and that's the length that we're trying to find out. Now, since we want to find out what the length of the c side is, all by itself, not what it is squared, we're going to take the square root of both sides of our equation. And on the left-hand side, now we have the square root of the x sub 2 minus x sub 1, the further x coordinate, minus the other x coordinate. So we have again 5 minus negative 3 squared plus 4 minus negative 2 squared. This is going to be equal to the square root of c squared, which is equal to c. Now we can simplify things a little bit. 5 minus negative 3 is going to be 5 plus 3. So it's 5 plus 3, which is equal to 8. So that's going to be 8 squared. And we're adding that to 4 minus negative 2. Now minus negative 2 gives us a plus 2. So that's 4 plus 2. So we've got now a 6 squared. So on this side, we've got the square root of 8 squared plus 6 squared is equal to c, which is actually equal to the distance. And let's clear a little bit more real estate up here. Now, when we do the squaring, which is required underneath this bracket, we get 8 squared, which is 64, and 6 squared, which is 36. And that's going to be equal to c, which is the distance between the 2 points. Now 64 plus 36, well, 6 and 4 is a 10. 0 there, bring up the 1. And 6 and 3 gives us a 9, plus another 1 will give us a 10. So now we've got the square root of 100 is equal to the distance, and the square root of 100 is 10, and that is indeed the distance of this side. So we've seen the derivation of the distance formula, which is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this very imposing equation turns out to be just the recipe for how to apply the Pythagorean theorem to find the distance of the third side.